Hello, everybody, and welcome to today's webinar presentation, Exploring IoT Time Series Data, brought to you by InfluxDB. I would like to introduce you to our presenter. Samuel Chevrier is a technical marketing engineer at eSoftThings with over 15 years of experience related to smart metering. These span from several Silicon Valley industry grades like Silicon Laboratories, STM Microelectronics, Ericsson, and Capgemini. And now I would like to pass it off to Samuel.
Okay, let's go. So, hello everybody, and welcome to the webinar. The webinar title of today is Exploring IoT Time Series Data with eSoftLink and InfluxDB. So, big title. What is the agenda for the presentation? For eSoftThings, very briefly. Then I will set the scene. I will explain what is the smart metering in France today, how it looks like, the architecture, and the network limitation. Then how we did to transform a smart meter into an IoT node to answer to this limitation. A bit more about the feature list of our IoT platform that we call eSoftLink. Some explanation about the GDPR restriction and the personal data that you need to take care about. A more deep overview of eSoftLink IoT platform architecture. Then why we choose eSoftLink database as a solution for our IoT platform, the type of data that we exchange and the tests we've done. And we will end by a demonstration of the full system, so the backend plus the mobile application. Let's start by the company. So who we are. We are a tech company, solution focused. We've been founded 5 years ago in 2014. We are based in Rennes, Brittany part of France, which is not that far from Paris. So 1 hour and 15 minutes now by the high-speed train. Our customers are based in Europe, North America, and Asia mainly. We are mainly coming from the creator of the company, from semiconductor industries, so Renesas, ST Microelectronics, and so on. So we do know well all that is linked to silicon, embedded software, mobile application, backend software as well. And the team of, we have a team of over 50 engineers today that is split into hardware and software activity. And we are mainly driven 2 units. We are having the smart device business unit and the autonomous vehicle one. The one I belong to is the smart devices business unit. So first, let's talk about the smart metering system in France, which is where our lead customer, Total Direct Energy, applied is the system for the customer. The European Union that says that 20% of energy saving must be done by 2020. So the 27 countries in Europe have to propose some technical solution to achieve this target. Smart metering is an obvious one. And what France was doing is a rollout of what we call today Linky smart metering. So on the picture on the top of the slide, you see the Linky smart meter in green. So it's about 23 million meters in France that communicate through power line communication on low voltage network to a concentrator. So it sends all the consumption data of the day only once at the end of the day with a 30-minute granularity. So what does it mean for the end customer? The end customer can connect to a web portal that is available for him to consult. And he can consult his own energy consumption data on a yearly, monthly, or daily basis. But he will be able to consult those only the day after, okay, and with a 30-minute granularity only. So it's not the easiest way for one who wants to reduce their energy bill at the end of the month to check what was the consumption of the day and what is the biggest contributor, is there any failure, and so on. And it's not only me that says this. There are some studies that have been conducted either by the National Science Research Institute in France, or by the Oxford University, or the American Council for an Energy Efficient Economy. And they are all saying the same. If you want, or if one wants to save some energy at the end of the day, the most efficient is to provide a real-time feedback tool. This way, the consumer, the end consumer, can save up to 12 to 15% at the end of the day. So it's a save in energy and it's a save in money, of course. Based on this, we decided to create an IoT sensor from the smart meter deployment. Okay, so what we did is transforming the smart meter into an IoT sensor for our lead customer, Total Direct Energy. So first things that we've done is created the IoT node, which is the small gray thing with 3 pins that you see in the end on the picture. So there is an available communication interface slot on the smart meter that we call TIC interface. We use this communication interface for the IoT node to communicate with the smart meter and retrieve all the register for production, energy production, and energy consumption. We used it as well to power up the IoT node. Then, thanks to a mobile application and a Bluetooth connection, we do some network provisioning on the IoT node so that it can connect through the Wi-Fi to the setup box of the home and send all the data from the smart meter to the IoT platform eSoftLink. It sends the data at every second. And we build the entire chain. So we build the IoT node, we build the IoT platform, the mobile application for the end customer, the dashboard for the administration for Total Direct Energy. So we provide the full solution to the end customer to transform the smart meter network into so from a 30-minute monitoring device to a real-time monitoring device. So a bit more about eSoftLink. eSoftLink is a versatile and robust end-to-end IoT platform. It's designed to work standalone on the customer infrastructure or on the edge or in the cloud, private or public cloud. It provides real-time data collection, data management, analytical and reporting tools that allows business to benefit from data collected quickly, efficiently, and securely. So what are the strengths of the platform and of eSoftThings, who is the provider of the platform? We are one of the provider that can enable your business. So we can design the sensor, the backend, the web app, the mobile apps. It can do some real-time monitoring system with a price that is not mapped on data or volume periodicity. It can be hosted, I told you already, on a public or private cloud. And of course, we respect the GDPR with careful care of the personal data. The feature list of eSoftLink IoT platform. So what is inside? eSoftLink provides data collection, of course, to gather all the data sent by the smart meter to the backend. Data visualization, at the end, one must visualize all the collected data. Data storage, data analytics to provide additional services to the end customer. Smart contract and device management. The key feature, we can scale the solution from 1 message a day to several million messages per minute. We do some real-time monitoring and alerting by email or application using push application using notification. On the edge, commercial cloud service or in the private cloud, we talked about it already. Security management, so we are GDPR compliant and we are using state-of-the-art secure protocol, let's say, like TLS or HTTPS. We are doing integrated AI analytics and with secure connection to data lake if required. The platform is able to manage the device, so to do device management with firmware update, remote logs, remote debug with auto diagnostic capabilities. And we have an administration console with some customizable panel and interfaces. I talked about GDPR. So what is GDPR in Europe? That is not only in Europe, but going to US as well today. So is General Data Protection Regulation. So this is a European law on data protection and privacy for all the citizens of European Union. There are some features that you need to implement in your solution to be GDPR compliant. So first, the right to be forgotten. Delete all the data of the database that are linked to a person. The right to consult. So an individual can download all the data that is related to his own account. Data portability. You are not locked to a single provider, and you must be able to extract all the data related to a personal account, either in CSV format or any other format, to be able to transfer to a different provider. Data log access. You must monitor each access to any database in your implementation and log any user details so that you know at any time who consults which data. And anonymization, no personal information stored into the Influx database. A closer look on the architecture. So what do we have in eSoftLink IoT platform? So first you have the IoT node on the left of the slide. So there are two types of link, let's say, with the eSoftLink IoT platform. So the FOTA link dedicated to firmware over-the-air upgrade, and the data path, let's say, the communication link. So first, we have a message broker that we implemented on our own to collect all the message coming from the IoT node. We have a device management block that will manage the status of the IoT node. Is it alive? Does it send data? What is the version of the firmware? Doing some firmware update and so on. We have some analytic. We have an analytic block. Sorry. So to do some prediction for energy consumption, some non-intrusive load monitoring, so that we call NELM. NELM is the capabilities to distinguish the different contributors into the main energy curve. So with your main energy register, you are able to say how much consume the fridge, the heating system, and so on. We are doing some clustering also, some AI with clustering. I will come back during the demo on this, plus some notification. So we have some batch that runs at the end of the day to compare all the data collecting during the day and do some notification regarding the one that activate the customer, the end customer. We do have the Influx database system, of course, to manage all the time series data that are coming from the IoT node. We do have another database that is more related to customer IDs. We have an alerting system plus an administration web panel. So this is all for the eSoftLink IoT platform. And to visualize the data, we do have the admin front end and iOS mobile application or Android mobile application. Depending on needs, we can have some customer data lake output and some connection to customer databases. What are the technology that we used for this implementation? So we do have our own message broker that we implemented inside the eSoftThings, sorry. We do have the Apache Zookeeper, which is the centralized service for the configuration and the distributed synchronization. We do have Kafka Stream to handle the real-time data feeds. We do have the Telegraf plus Influx database to manage the time series database, and Telegraf, which is the server agent for collecting and sending the metrics and events from the database. What we are using to build all the customer graphics and administration graphics is a Chart.js library. So a JavaScript library, which is quite convenient to build your own customized graphs. So why did we choose Influx database for implementation? First reason is the amount of data that we are collecting, 24 hours, 7 days a week at a 1 second rate for more than 10K devices. So it's at the end of the day, it's a huge amount of data that you have to deal with. So to read, to store, to request, to collect. So we needed a robust time series database, and I guess Influx database is the best solution for this. We needed a scalable solution, so the enterprise edition was a must for us. We needed a popular solution, and Influx database is very popular today on the IoT market with more than 17,000 stars on GitHub. So why we choose a popular database? So it's easy to implement and to find documentation to guide you, thanks to the community. And the popularity is also a guarantee for long-term support. And of course, we did some load tests so that we were convinced that the Influx database was the one we needed. So what we did is loaded the server with 48,000 users, 1 data per second per user, and 2 tags per data to write into the database. And then we monitored all the instance and server to check that the loading was correctly shared. What was the result of this test? So regarding Telegraf, the CPU usage, so with 6 instances of Telegraf over 3 per server, sorry, so over 2 servers, we had a mean of 63% of CPU usage per server. So it was all good for what we need to achieve. The traffic, so the amount of data managed by the Telegraf server, 6 instances in total still, and a mean of 460 megabits per second overall traffic, so in and out aggregated together. and 63% of RAM usage, 4% of cache, and 0% of swap, because there was no need for swap at this stage. So regarding Telegraf, it was all good for the tests we've done. Now regarding Influx database, for the CPU first. So we had 2 instances on 2 servers, and it was 43% of CPU usage per server. So we were very good for the test. We had 360 megabit per second traffic on both servers, in total on the 2 servers. And we had 58% of RAM, 63% of cache, and 0% of swap still for the memory. So with the dimension that we and the topology of network that we picked up, all the solution was working fine, and we were far from the limit thanks to Influx data management. And now I will continue by a small demonstration to show you what looks like the solution for Total Direct Energy. So what the customer is able to have, and what the utility, the energy provider, is having on his side to manage the solution. So first, about the mobile application that the end customer is having on his side. So it looks like what you can see on the screen. So we have 3 main menus. So one regarding the alert, one to consult all the energy consumption data, and one configuration menu, let's say. So in this first configuration, you can first manage your alerts. So we do have alerts for consumption monitoring, for prevention, or for operation. You can enable or disable all of them. Okay, so consumption, you can have some monthly consumption alert, weekly, daily, based on energy daily consumption limit or budget limit per day. We do have some prevention. So when you get close to your contract, and in order to avoid the fuse limit, you can get an alert just before the fuse will be triggered, so that you can avoid the blackout. We do have some maximum power alert and minimum power alert too. And we do have some operation alert in case of the connection is lost from the IoT node, so that you can check what is happening on your communication network. Then we have some home comparator tool. I will come back on this later. You can have some consumption change graph here, so to check what looks like your consumption today in comparison of yesterday, or on 7th day or 30 days. And you have your main information available. So what is your profile, the reference consumption, and some tips to use the app. So now how you consult your own energy data consumption. So it's a real-time demo. So I do have for real a small Atom key connected to a smart meter that is running here in the lab. The small points that you see that are going to the smart meter are corresponding to watt per hour. So you can see the number that is increasing. So you can check your consumption for today, for this week, for this month. Okay. You can check your power usage in real time. So right now, it's 983 watts. and you can see your pricing information. So you can get some different prices of energy regarding the different time of the day. So it gives you some information of what is the current price regarding and in regards of your contract as well. Okay. And I talked to you about some comparison tool. Okay, so if we go here, for example, so you can have your consumption figure based either in money spent or energy. Okay, and you can check what is your consumption and compare it to similar homes. Okay. So when you enter the mobile application, you do some light configuration, and you say how much is your house. So here it's 70 square meter. You are 3 inhabitants in the house, and your heating source is not electric, and you set your location. And then we are doing some clustering comparison, and we classify your information and compare to some other information in similar configuration. So here, for example, your consumption is the consumption of the atom key or of the smart meter is 48% higher compared to similar properties. So it's very convenient to determine if there is any isolation issue in your house, or if you put the temperature too high, or if there is a device that is failing, consuming too much energy in your house. Okay. And then we have some alert management here for the customer to manage his own alerts. Okay. I think it's okay now for the mobile application, for the end customer to check his own power consumption and energy consumption. How what will be the billing at the end of the month? And now a small look on the administration dashboard and tool that we are offering to the energy provider, so to the utility. So thanks to this tool, the energy provider can manage his own IoT devices, all the devices that he sent to his own customer. They are all here, so he can monitor in real time the network. So here is a first dashboard with the KPIs defined together with the customer. So the number of active sessions at the time, the connection today, the number of user accounts, the average session duration. So how long is staying each customer in the application. The energy consumption aggregated for yesterday, and the instantaneous power. And here is a funny one, is a number of coffee. So we added this one for a trade show for European Utility Week 3 months ago, and it was a demonstration that we did for NELM. So NELM, non-intrusive load monitoring, I talked about it. So we were able to detect the coffee machine consumption, energy consumption on the final energy figures, okay, on the final power consumption figures. Okay, so this is also some nice figures that the utility can check. So this is all the firmware version deployed on all the IoT nodes. So you see here that most of them are using one of the latest, so 1.6.2, which is good. The number of new IoT node installed per day is registered here as well. The number of iOS user with connected IoT node, Android user with connected IoT node. Here is the number of IoT node that is connected and the number that is disconnected for any reason. One could be a Wi-Fi access point name or a password that has been changed at home, or some failure from the set-top box, or any other reason. The type of OS used for the mobile application. So here Android is preferred to iOS apparently. The evolution of the number of nodes that is connected per day, the unique connection over the last 10 days, and this one we already talked about. So this is the dashboard. Then we have the user database. So the utility can consult any of the customer who installed the IoT node on his own smart meter. So here, for example, the one that is connected and that corresponds to the mobile app that we saw before is Luna Adeline. Of course, is dummy data here does not correspond to a real person. Okay, so thanks to the administration, we know a bit more parameter on the IoT node. So what is the status? It's paired, it's connected, and it's plugged in the meter. The firmware updated last time on the 22nd. We have the hardware version and the software version. Okay, we have all the description during the eligibility stage. So during installation, what kind of issue faced the end customer. Some information about the phone application, the phone itself, and the application used by the customer. Some more information about the consumption monitoring. So we saw right before on the application, mobile application, when we looked at the light, it was about 1 kilowatt that we see here as well. And you can see those in power, in energy, okay, in money as well. And we have some nice prediction that I didn't talked about as well, that is available and valid for the end customer as well. So on eSoftLink, we have some connection to weather forecast tool. So thanks to the history of your power consumption data and the prediction for the weather forecast, we can determine or calculate what will look like your power consumption in the next week, let's say, in the coming days. So this is here, okay. And we still have the same home comparator tool that I show you on the mobile application. Some more information about the meter itself. The notification information. So what kind of alert has been enabled for this end customer. The notification status. So what kind of issue have been recorded. Personal information and GDPR log. So I talked about it. You must log who is consulting the personal information at any time. So you see, this is just the account I logged in on the backend. So I can see that right now I'm consulting and listing this account. Okay, this is all for the user panel. Now for OTA management. So it's one challenge to have an IoT network but it's another one challenge to be able to maintain it and to operate it. And thanks to this menu, you can operate it easily. So you can put here any firmware version that you want to deploy. You load them on the IoT platform, and then once a day, every IoT device will come and request to the eSoftLink platform what is the latest firmware that is stored on the IoT platform, and it will download and install it if this one is more recent than the one installed currently on the IoT device. Okay, and some small information about the account and a logout session. And this is it. I hope you appreciate the webinar and that the explanation were good, and that today you see better how to benefit from IoT technology plus Influx database technology to manage your IoT project.
Okay, thank you very much, Samuel. And now we'd like to move on to the Q&A portion of the webinar. So audience, if you do have any questions, please make sure to post them in the questions panel. But I do have a few already that I would like to start with. Okay, so for starters, are you using any kind of forecasting tools for both the consumer UI or the service provider UI?
Yes, right. We are using weather forecast tool that you can subscribe on. The weather forecast tool is used for the consumer UI mainly. So it's used for prediction, so that the customer can know what will look like the power consumption in the coming days. So this is for now the only use that we are doing with this, but we have some more in mind and in the roadmap. For example, the energy producer will want also to access some prediction tool, so that they can know in regard of the production type, that energy type that they are having, what will look like the production curve in the coming week. Okay, so today it's only for consumer, but we are thinking to deploy it for energy producer as well.
Okay, another question that was asked is, do you use MQTT for node to server communication?
We do not today. But it's the platform is compatible with MQTT. But for this customer specifically, and for the energy management deployment, we didn't use MQTT.
Okay, a third question is, how do you manage non-communicating meters?
It's a good question. So the IoT node is bringing communication to the smart meter, which was already communicated, but through PLC. That is sometimes not that convenient, let's say. Now there will not be 100% coverage on the network, because sometimes the meter is far from the Wi-Fi setup box and is not covered by the Wi-Fi network. You have several solutions. Either you create another type of IoT node with a dedicated sub-gigahertz RF connection, for example, so that you increase the coverage of the customer network, and you install, for example, a small communication IoT node inside the house that is communicated with the RF sub-gigahertz signal with the meter that is having the same protocol embedded. So instead of Wi-Fi, you're using something else, or you are using some Wi-Fi extender, which are very cheap today, so that you can increase your network coverage and have more percentage of the fleet of smart meter that is able to use this type of tool, let's say.
Okay, thank you. Another question is there any process to trigger or send commands to the meter? Examples being restart the meter or set a tariff?
Yes, we can send some command to the meter. For example, as long as the interface communication between the meter and the IoT node supports it. Okay, so we can send some request command for an auto diagnostic request to the IoT node that is connected to the meter. Now, we did not specify the interface between the meter and the IoT node. It was an interface that is already there. And we cannot order the meter to shut down or to do anything that has been not specified ahead, I would say. So it's more a matter on the smart meter vendor than on our side. As soon as the functionality is there, we can do it.
Okay, thank you. We have 5 more questions.
Okay.
One of them being, for the InfluxDB, do you use that as your primary database, or do you replicate that data in another database / data store?
If I'm not wrong, we are replicating. But I will double check this one, of course. But for what I know, we are replicating the first database.
Okay. Another attendee is wondering which protocols are supported for node-to-meter communication like DLMS.
Sorry, I didn't catch this one.
Which protocols are supported for node-to-meter communication like DLMS?
DLMS. Okay, so DLMS COSM model is more implemented inside the smart meter, as long as I know, and we are inherited this data model on our side. So we do not manufacture the smart meter itself, but we are able to request any of the DLMS COSM database object that is already defined on the smart meter one, and check its value and report it to the IoT platform.
Okay, thank you. Another attendee is wondering, the nodes are Wi-Fi supported, or is it possible to use 3G or 4G as well?
So we do have the Wi-Fi version today, and we are working on LTE modem version, or LTE model, or cellular model version, so that we can, it's linked to the first question that you asked at the beginning, I would say. So to increase the coverage for the meter that are not covered by the Wi-Fi network today, cellular version is ongoing and is something that we are implementing. So it's not existing today, but is scheduled and in the plan.
Okay, 2 more. How do you manage the message order, considering that messages can go out of order?
Sorry, I do not understand this one. Can you repeat?
How do you manage the message order as messages can go out of order?
If messages can not go out from the IoT node, you mean?
I believe that the attendee is just wondering how you can control the order of the messages.
Okay. The order of so we are treating the messages that are coming from the IoT node as they come, and thanks to the network topology that we've put in place in the back end, thanks to the treatment that the fast treatment that we are doing, we are able to manage a queue, first in, first out, let's say, and we are able to manage all the messaging that are sent by the smart metering system and the IoT node, I would say. So first in, first out is the answer.
Okay, thank you. And our last question today is, what are some other things that you guys are planning for the next iteration of this project?
Yeah, so we are having a unique access, I would say, to the customer that is using the application, and we are seeing some upcoming feature like vehicle to home. We believe that tomorrow, when the electric vehicle will be largely adopted on the market, there will be a real challenge to manage the overall energy in a country. So vehicle to home is a feature that we want to implement on the platform. So for example, you go home and you plug your car, and you will be able, thanks to the application, to say, okay, I will leave my house tomorrow at 8 a.m. and I want the battery to be 70% charged, so that the network will manage the load and the peaks correctly. So this is one of the features. Microgrid management is another one. So we want to be able to better manage communication between energy producer and consumer, so that there can be some exchange in value between the producer and the consumer. So microgrid is another topic, and NELM for sure. So non-intrusive load monitoring. We want to be able to give some insight to the end customer at the end of the month, what was the biggest contributor into the energy bill, and is there something to change in the house to have a better energy efficiency. So this is another AI algorithm that we are working on.
Okay, and with that, I would like to thank Samuel for a great presentation. I would also like to thank InfluxData for providing the audience with a great webinar. Lastly, thank you to everyone who attended the webinar today. We hope you learned something new that will help you in your developer career. Have a great day.
Thank you, bye.